Hello students, I am Vishwanath. Welcome to my YouTube channel Best Physics Guide by Vishwanath. Today I am going to discuss about X-ray. This is a vacuum glass tube and it is a cathode. It is made by some filament or metal wire and it is connected with a low potential difference battery, and therefore this filament is heated up, and this cathode is also connected with a battery having high potential difference. This filament is connected with the negative pole of the high potential battery, and this is a target which is made by molybdenum, tungsten, etc. And this target is made by some strong metals, and this target acts as an anode and it is connected with the positive pole of the high potential difference battery. The potential difference between the cathode and anode is very high. It is almost 10 to the power 3 volt to 10 to the power 6 volt. Now cathode ray is produced from the filament or cathode. You know that cathode ray is the flow of electrons. These electrons move with very fast and hits the target, and due to the collision between the electrons and the targets, X-ray is produced. X-ray is an electromagnetic wave, and we can treat the X-ray as the photon particles according to Einstein's or according to quantum mechanics, and the X-ray is also considered as a photon particle. And you know the energy of a photon particle is directly proportional to its frequency. Therefore, maximum frequency of the photon particle is directly proportional to the potential difference between the cathode and anode. Since initially the potential difference between the cathode and anode produces some potential energy of the moving electrons. This potential energy after that converts into kinetic energy of these electrons. This kinetic energy then converts into the energy of the photon particles of the X-ray. Now, from the principle of conservation of energy, we can write that H into nu max is equal to small e into capital V. Here H is the Planck constant and nu max is the maximum frequency of the X-ray which is produced in this Police tube, and small e is the charge of an electron and capital V is the potential difference between anode and cathode. And you know that nu is equal to hc by lambda, where lambda is the frequency of the radiation. Therefore, lambda minimum or wavelength of the X-ray, minimum wavelength of the X-ray, that is lambda minimum, is equal to hc by small e capital V. Here h, c and small e are constants. Therefore, now putting the values of h, c and small e, here c is the velocity of light in vacuum, and we get that lambda minimum is equal to 1243, that is 1243 by capital V nanometer. From this formula we can easily find out the minimum wavelength of the emitted X-ray when we know the potential difference between cathode and anode. Next, soft X-ray and hard X-ray. When the wavelength of a X-ray is from 0.01 angstrom to 10 angstrom, then it is known as soft X-ray. And when the wavelength of a X-ray is less than 0.01 angstrom, then it is known as hard X-ray. The penetration power of hard X-ray is greater than the penetration power of soft X-ray. That is, hard X-ray can penetrate more than soft X-ray. Next, continuous X-ray. If we plot the intensity of X-ray with the wavelength at a fixed potential difference, we have the bear-shaped graph. That is, the intensity of X-ray initially increases with the increase of the wavelength. After some time, it becomes peak and then it decreases with increasing lambda. These X-ray are known as continuous X-ray. Here, when an electron strikes a target, then its energy changes, kinetic energy changes. Let initial kinetic energy of the coming electron is half mv1 square, and when it penetrates the target atom, then its kinetic energy becomes half mv2 square. Therefore, this change in kinetic energy of the electron, which is produced from the cathode, then the change in kinetic energy is converted into the X-ray, and energy of X-ray is hc by lambda, where lambda is the wavelength of the X-ray. Therefore, hc by lambda is equal to half v1 square minus v2 square. The electron which emits from the target atom can again strike another atom. In this way, this electron can strike many atoms, okay, of the target metal. Therefore, we get continuous X-ray. Actually, due to the collision of the huge amount of electrons coming from the cathode with the target metals, produces continuous X-ray. Next, continuous X-ray. When the potential difference between the cathode and anode is very huge, that is, it is almost 60 kilovolt potential difference between anode and cathode, then we got some peak in this curve. These peaks are known as continuous X-ray. Okay, these peaks are known as continuous X-ray. When the potential difference between the cathode and anode is very high inside the Coolidge tube, then the incoming electrons have huge potential energy as well as then it is huge kinetic energy. That is, it strikes the target with huge velocity. That's why when the incoming electron strikes the orbital electron of the target atom, then the orbital electron can displaced from its own orbit. Let us consider this incoming electron strikes the orbital electron at k cell. Therefore, this orbital electron then displaced and there creates an empty space inside the K cell. You know that a K cell can occupy maximum 2 electrons and 1 electrons is displaced. Therefore, an orbital electron jumps from the outer cell to the inner cell. That is, an electron may jump from the L cell to K cell or M cell to K cell. When an electron jumps from the L cell to K cell, then the characteristic X-ray is known as K alpha. And when an electron jumps from the M cell to K cell, then it is known as K beta. Okay, in this way we can got L alpha, L beta, M alpha, M beta, etc. These peak or these rays are known as characteristics X-rays. Let nu be the frequency of the characteristics X-ray. Then it can be proved that nu is equal to C R capital R Z minus 1 into 1 by NF square minus 1 by Ni square. This formula I already proved in my previous video. Here Z minus 1 is written as when an orbital electron is displaced, then the remaining number of electrons is Z minus 1. Here Z is the proton number of the target atom. Therefore, nu is equal to C capital R Z minus 1 into 1 by NF square minus 1 by Ni square. And for K alpha characteristics X-ray, Ni is equal to 2 and NF is equal to 1. That is, the electron jumps from L cell to K cell. Therefore, and we know that capital R is equal to 1.097 into 10 to the power 7 per meter, and C is the velocity of light in vacuum, is equal to 3 into 10 to the power 8 meter per second. Therefore, we can say that root of nu, that is square root of the frequency of the characteristics X-ray, is directly proportional to Z minus 1. It is known as Moseleys law. This law states that the frequency of the characteristics X-ray depends on the proton number inside the nucleus of the target atom. It does not depend on the atomic weight of the target atom. Frequency of the characteristics X-ray depends on the atomic number or proton number of the target atom. This is known as Moseleys law. By Moseleys law, we can rectify the Mendeleev's periodic table, and we can establish Bohr's atomic theory by this law. Therefore, Moseleys law carry many importance in physics as well as chemistry. Now, the uses of X-ray. You know that X-ray is used in medical science, in chemistry and physics. X-ray react with photographic plate. X-ray can penetrate our bodies except bones. That's why we can we can we can produce photos of bones, our bones, by X-ray. X-ray can ionize gases. So X-ray has many uses, and it can also use uh, to dictate the crack inside some matter or solid bodies. So today I'm going to finish my video. I think you can understand this topic, and thank you for watching my video, and please subscribe my channel.